Okay, so what you're going to figure out for the rest of the semester is that we're actually done with Algebra 2. So we are going to start our study of trig for the rest of the semester. We're going to do this in 3 separate units. The first unit is going to be geometric trig. So what we're going to do in this unit is relearn and recover all of the trig that you learned last year in geometry. So we're going to do things like special right triangles, we're going to do SOHCAHTOA, we're going to talk about solving right triangles, and we're going to talk about law of sines and cosines. So we're going to put together all of the things that you learned last year in geometry, whether you had honors geometry last year, whether you had GOA last year, you learned all of the material. So the first thing we're going to talk about is special right triangles. Special right triangles is a way to figure out missing lengths of a triangle as long as the angle measures match up to the patterns for each one of them. So the first pattern we're going to talk about is 45, 45, 90. In a 45, 45, 90 triangle, what you'll notice is that this triangle over here on the left, on the right, both legs are the exact same. The reason why is because in a 45, 45, 90, you have 2 base angles that are congruent, which means you have 2 legs that are congruent. It's an isosceles triangle. The legs are both labeled here as x, and then the hypotenuse is labeled as x square root of 2. I want to figure out the hypotenuse of a 45, 45, 90. All I do is multiply the legs by root 2. So for example, if I told you that both legs were 4, that would tell you that the hypotenuse was 4 square root of 2. So we're just taking whatever the legs are and multiplying by root 2. So coming down, looking at the problems that are there, the first one, I have both legs labeled as 3. So all I have to do is multiply by the square root of 2, and the hypotenuse is 3 root 2. In the next triangle, it's actually the exact same triangle. Notice this time that you're given the hypotenuse, and if you want to go backwards to find the leg, we're going to divide by root 2. So very simply, if you divide by root 2, they cancel out, and each of these x's is just 3. The next example on the right, if one of the legs is 4, that means the other leg is 4. And then in order to find the hypotenuse, all we have to do is multiply by root 2. So we get an answer of 4 root 2. Now, the most common misconception with these triangles is that the hypotenuse always has to have a root 2 in the end answer. And that's not always the case. In the next 3 problems, each one of these is going to have a hypotenuse that is not having a square root attached to the answer. Doesn't mean we're not going to use root 2, just means it's not going to be in the final answer. So notice in the next one, the root 6's are both legs of the triangle. So if I want to find the hypotenuse, I'm still going to multiply by root 2. Now, with our knowledge of square roots, we multiply those to get square root of 12. And then we would have to break down that answer. So root 12 does break down root 4 and root 3. And so my final answer is going to be 2 square root of 3. So in this problem, think about it. Root 2 doesn't necessarily have to be in the final answer. It just is used to find the final answer. The next problem, we're given the hypotenuse. So just like the problem directly above, we're going to divide by root 2 in this case because we're going backwards. Again, with our study of roots from earlier this year, we know that this is not acceptable. So we're going to multiply by root 2 top and bottom. We get 12 root 2 over 2. And if we simplify, the legs are both 6 root 2. In the next one, again, we're given the hypotenuse, so we're going to do a similar thing. We're going to divide by root 2. Again, just like the last one, that's not acceptable, so we're going to rationalize the denominator by multiplying by root 2. Notice that the 5 over 2 doesn't reduce in this case, so so that kind of gives you a quick rundown, a quick review of 45, 45, 90s. I will tell you, and you're probably going to want to write this down, as we progress more advanced with this, we are going to start looking at 45, 45, 90s in this manner. we're going to look at them as the legs being 1 and the hypotenuse being root 2. That's going to come back. So when we look at a 45, 45, 90, I kind of want you to have the idea that it's a 1, 1, root 2. And we'll talk more about why that is when we get into the next unit. But for now, I just will kind of want to bring that up so that when I bring it up again, you kind of can remember that I said that. Coming down, the next set is going to be 30, 60, 90s. So in a 30, 60, 90, the legs are different here because the angles are different. So I always call the angle or the side length across from the 30 degrees the short leg, the one across from the hypotenuse, the 60 degree angle, the long leg, and then the one across from the 90 degree is the hypotenuse. So everything here is based off of the short leg. If you know what the short leg is, the hypotenuse is just the short leg multiplied by the square root of, multiplied by 2, not the square root of 2, just by 2. And if you want to talk about the long leg is just the short multiplied by root 3. Just like the previous examples, if you want to go backwards, it's division instead of multiplication. So if you're given the hypotenuse and you want to go to the short leg, we wouldn't multiply by 2, we would divide by 2 in that case. If you want to find the short leg and you know the long leg, we would divide by root 3, not multiply by root 3. So similar type concepts, just different numbers we're using with these triangles. So what you're looking for in each of these is first, what side length are you given? Well, the 6 is the short leg. Finding the hypotenuse is really easy. All we have to do is double that value and you get 12. Finding the long leg is just multiplying the short by root 3, so we just get 6 root 3. This is all about memorizing the pattern. Then that's really the only way you can do special right triangles is to memorize the patterns. Problem, the 12 root 3 is the short leg because it's across from the 30. So if I want the hypotenuse, all I have to do is double that. If I double 12 root 3, I get 24 root 3. The long leg, we take the short, 12 root 3, and we multiply by root 3. Roots together just gives me 3, and 12 times 3 is a length of 36. 3 root 2 is across from the 30, so it's the short leg. If I want the hypotenuse, I'm going to double. 3 root 2 doubled gives me 6 root 2. If you want to figure out the long leg, take the short and multiply by root 3. If I multiply those roots together, I get a final answer of 3 root 6. Again, special right triangles is all about memorizing the pattern. In the next 3, these are 3 problems where you're not given the short leg to begin with. In this problem here, we're given the long leg to begin with. So if I want to go backwards and find the short leg, I'm not going to multiply by root 3. I'm going to divide by root 3. Well, the root 3 simply just cancel out, and I get a short leg of 14. Finding the hypotenuse is still doubling the short leg. So 2 times 14 gives me a hypotenuse of 28. So if you don't know the short leg to begin with, that's the first thing that you have to. In the next problem, the 6 is again the long leg because it's across from the 60. So if I want to go backwards to the short, I have to take the long and divide by root 3. Going forwards from the short leg is we're dividing, not multiplying. Now with our study of roots, we know root 3 in the denominator is not acceptable. So if we rationalize, we get 6 root 3 over 3, which gives me a final answer of 2 root 3. Finding the hypotenuse is just doubling what I just found. So 2 root 3 doubled gives me a hypotenuse of 4 root 3. The 8 that's here is the hypotenuse. So if I want to go backwards to the short leg, we're going to use division, and that division is pretty easy. Just divide in half. So Long leg is just that multiplied by root 3, so simply just 4 root 3. Again, special right triangles is something that you're going to need to memorize the patterns for. They're going to show up a lot when we start getting into more complex trig. Just like I showed you with a 45-45-90, here's how we are going to look at these when we get more advanced. So I have a 30-60-90. We're going to look at this as a 1, 2, and a root 3. So notice all I've done really is take off the x's. That's not now, but when we get into the next unit and we start talking about things like sine of 120 degrees, what I just wrote up there is going to become very important. The fact that I know that a 30-60-90 can be written as 1, root 3, and 2. So just kind of a mental note, so when I bring it back up, you can say, yeah, Mr. E, I remember you saying that in class. If you have questions about special right triangles, make note of them so that you can ask next class. Okay, so on the back side of this, we're going to get into our SOHCAHTOA. Now, trig ratios of any right triangle, as long as I know that the triangle is a right triangle. It can help me find missing lengths, which is what we're going to use it for today. It can also help me figure out missing angle measures, which is what we'll use in the next lesson. We're going to use inverse trig ratios. Now, last year in geometry, you probably learned these 3 trig ratios, sine, cosine, and tangent. This year, we're going to add on 3 more. We're going to add on the reciprocal trig functions, which are cosecant, secant, and cotangent. Each one of those is a reciprocal of one of the ones that you learned last year. So notice your identities here. We're saying that cosecant is the same thing as 1 over sine. So in other words, if sine is opposite over hypotenuse, that means that cosecant is hypotenuse over opposite. So it's the same 2 sides of the triangle, we're just using the reciprocal of the fraction instead of opposite over hypotenuse. Secant goes with cosine, so secant, instead of being adjacent over hypotenuse, is actually hypotenuse over adjacent. And cotangent is the reciprocal of tangent. So if tan is opposite over adjacent, cotan is adjacent over opposite. Some other things to note, look here in this triangle, we've got a little, a different symbol. That's called theta. When we start talking about trig, your book will start using Greek letters rather than using X, Y, Z like you're normally used to. So you'll start seeing things like theta and beta and alpha and so on. So it's not really any different. It's just a variable. We just tend to use Greek letters to represent angles rather than using X's and Y's and so on. So don't get afraid or don't get frightened by that. It's just a different variable that your book was using. So I'll probably use it quite a bit also. So in the first problem here, it says evaluate the 6 trig functions with the angle theta. So the first thing that you're going to notice is that one of the side lengths is missing. In a right triangle, if you know 2 of the lengths, you can always use Pythagorean theorem to find the 3rd length. So if I use Pythagorean theorem, I'm hoping that you recognize this is a triple. It's a 5, 12, 13 triple. If you don't recognize that, you can always solve it. You're going to get 13. So what we do here is we circle the theta so that I can label the sides as opposite, adjacent, and hypotenuse. The 12 would be the opposite, the 5 is the adjacent, and the 13 is the hypotenuse. And all we're going to do is say sine theta equals this fraction, cosine theta equals this fraction, tan theta equals this fraction. So sine is always opposite over hypotenuse. So in this case, the opposite and hypotenuse are 12 and 13. So sine theta is 12 over 13. Cosine is always adjacent over hypotenuse. So adjacent and hypotenuse are 5 and 13. So 5 over 13. Tangent is always opposite over adjacent. So opposite and adjacent in this case are 12 and 5. So tan theta is 12 over 5. Now it says to evaluate the 6 trig ratios, the 6 trig functions. So we also need to do the reciprocals. So sine and cosecant are reciprocals. Cosine and secant are reciprocals, and tangent and cotangent are reciprocals. So all I'm doing is taking the fractions I already found and flipping them upside down. So the first one would flip upside down to be 12 over 13. The second one would be 13 over 5. The last one would just be 5 over 12. So your reciprocal trig functions are just exactly that. Find sine, cosine, and tangent, and all you have to do is flip them upside down to find cosecant, secant, and cotangent. Now, it's probably going to be difficult for you to remember which one goes with which for a while, because common sense probably tells you that cosecant should go with cosine, but it doesn't. Common sense would tell you that secant goes with sine, secant. Usually a hard thing for students to grasp because they always want to put the ones that would logically make sense together, and in fact they don't go together. So sine with secant, or sine with cosecant, cosine with secant, tangent with cotangent. The next two problems really aren't any different than what we just did, so we're going to skip those. And let's talk about the next one. So this one says an acute angle of a right triangle, and sine of theta is 4 over 7. What's tan of theta? Well, if you'll notice, the thing that's missing here is a picture. So what I'm going to do first is draw a picture. It says it's a right triangle, and it says one of the angles is theta. So there's my picture. Notice it says that the sine ratio is 4 over 7. Well, in my picture, the 4 and 7 have to represent the opposite side and the hypotenuse because that's what sine represents. This problem is asking me for tangent. Now, if I want tangent, tangent is always opposite over adjacent. So if I want opposite and adjacent, I have to find this missing side down here. Now, unlike the last one, this one isn't a triple. So I actually have to use Pythagorean theorem and figure out what that missing side length is. Let's see. 4 squared is 16, 7 squared is 49. Subtracting, you get 33, which means that that missing side is root 33. Now, if I want tan theta, we have to use the opposite from theta and the adjacent from theta. So we're using the 4 and the root 33. So tan theta is 4 over root 33. Now, if you'll notice, that's none of the answers because that's technically not simplified. So you need to rationalize the denominator, and we get 4 root 33 over 33. There is your answer, letter B. Anytime you're given what sides of the triangle that ratio is telling you. All right, coming down. So what can I actually do with trig ratios? I can use them to solve right triangles. So it says use a trig ratio to solve for x. So the first thing you're going to do in all these problems, circle the angle and then label the sides. X is opposite, 18 is hypotenuse. That means that I'm going to use a sine ratio. Sine of 55 degrees is equal to opposite over hypotenuse. We're going to come back and solve that in a second. And the next one, from the 35, the 4 is opposite and the x is adjacent. O and A tells me tangent. So tan of 35 equals 4 over x. And in the last one, x is adjacent, 15 is hypotenuse. So A and H tells me cosine. So cosine of 22 degrees equals x over 15. Now, how do I solve these? I'm not sure what your geometry teachers showed you and how to solve these last year. But to solve for x, it's really simple. Anytime x is in the numerator, like it is in the first one and the third one, you're just going to multiply to solve. So we're going to do 18 times sine of 55, and we'll get an x value. And we're just going to do 15 times cosine of 22, and we'll get an x value. Anytime x is in the numerator, you're just going to multiply. So the first one, we are going to come out with 18 times sine 55. We get 14.7. In the last one, 15 cosine of 22, we're going to get 13.9. Notice in the middle one here, x is not in the numerator, it's in the denominator. Since this one's set up a little different, we're not going to multiply to solve this one, we're actually going to divide to solve this one. So instead of 4 times tan of 35, this one is going to be 4 divided by tan of 35. So rule of thumb, anytime x is in the numerator, we're going to multiply. Anytime x is in the denominator, we're going to divide. Dividing this gives me an answer of 5.7. A couple of things to make note of. A lot of you have your own inspires, and so this is going to be very important. So please pay attention. In fact, if you have your own pulls up, that's going to give you a chance to take it out. So please do so right now. Okay, so if you turn your calculator on and you're on the home screen, you need to push the number 5, that takes you into your settings, and you do number 2, which says document settings, and the second one down right here, it needs to say degree. If your calculator says radian, you need to select it to be degree, and what you want to do is you want to tab all the way down, and you want to highlight make default, and you're going to click enter twice. If you don't do make default, it won't correct it in your scratch pad. So you need to click make default. Don't just click OK. So if you click twice, that means now that when I go into my scratch pad, that this will be in the correct mode. Radians is just another way to measure angles. It's not something that we're going to use until next unit. So it is something that we'll talk about next unit, but for right now, we're going to stick totally in degrees. So the last thing we're going to do is a word problem here. Anytime you have a trig word problem like this, the picture is just going to be a right triangle. So this says a parasailer is attached to a boat with a rope 300 feet long. So here's my boat, here's my parasailer. They're attached using a rope. The rope is 300 feet long. It says the angle of elevation from the boat to the parasailer is 48 degrees. If you remember from last year, angle of elevation means if I look straight out and then rotate my eyes up, what is this angle that I'm looking at? So in this picture here that I just drew, my 48 degrees would go in the bottom corner. I want to know what the parasailer's height is above the boat. So straight down is your height. So all I'm doing here is using a trig ratio. So in this case, I'd be using sine because the h is the opposite and the 300 is the hypotenuse. So sine of 48 equals h over 300. Just like the problems above, since the variable is in the numerator, we're going to multiply to solve. And all we're going to do is round to the nearest tenth of a foot. So let's do sine of 48 multiplied by 300. We get 222.9 feet. So that's how high above the boat that parasailer is. This should just be review. I'm hoping that this comes back to you. This whole unit should be rather easy for a lot of you because it's just a review of last year's trig you learned last year in geometry. So I'm hoping that's still the case. If you have questions, just make note of those questions so that you can ask in class.